Hello, everyone. I'm Brett Francis, and you're here at the Anatomy of a Successful IoT Project session, IoT202. And we have a few more speakers today. I'm Michael.
Hi, everyone. I'm Michael Garcia.
And then we have Jeroen from Pentair, right there. He'll be up here in a minute. And then Federico Senese as well. So what we're going to go through today is a set of information that we've learned by listening to our customers across the globe when it comes to IoT projects. And the agenda is going to walk us through kind of increasing levels of technical detail and specificity, where we'll start with some guiding principles. And essentially, if you leave with nothing else, we'd love you to take those and really take them into your organizations. We're going to go then through some characteristics of an IoT project and how they're successful, and then the best practices that are a little bit more technical as well. And we're going to wrap up with a nice, good session from Pentair, where they talk about how they've experienced these practices and come up with their own best practices as well. Michael?
All right. Thank you, Brett. So this session is about successful IoT projects. And Brett and I, we looked at a lot of customers, and we're particularly interested in knowing why those customers were successful when they were doing IoT. So we looked for mechanism and things that they were doing, and this is what we're going to give you in this session as knowledge in the form of guiding principle. So before we start there, one thing to look at for every project is who are the teams that are involved in the project. And some personas are the same as in traditional IT. There's still a business decision maker who is the person who is going to sponsor the project from prototype to pilot prototype and production later on. We have also the product manager, like in traditional IT project, but this time with IoT projects it's a bit different because the product manager are usually more involved. Why? Because now you got hardware to deal with, and sometimes there's constraints that comes with that hardware, and that can impact the customer experience. And then we have a persona who are specific to IoT. So the device engineer is the person who is going to build the hardware and the firmware that will go on top of it. The cloud developer needs no introduction. I guess most of the people here are familiar with it. It's the person who built the mobile and web application. And the operation analyst is the person who will transform the raw data coming from devices into actionable insights for the business, and also, most of the time, metrics for the product manager on usage of the devices. And last but not least, we have the security architect who is making sure that the whole solution end-to-end is secured from devices all the way up to the cloud and your backend systems. So before I start on the first guiding principle, Brett and I work together a lot all the time, and I made a small project on my own because I wanted him to be able to call me easily. So I have a button here that he can press, and that will call my phone. So we're going to demo that if you can click on the button.
Thanks. Okay. All right. Pushing the button.
All right. So now it's triggering a Lambda function using Amazon Connect. It's going to call Brett's phone, and then it will transfer the call to my phone. You see it?
Welcome to everyone at reInvent 2018 and hello, Brett. I will now call Michael. Please wait a moment.
All right. I think
I could have just used the speed dial.
Exactly. So, yeah. Indeed, what you just witnessed is the most useless demo ever shown at reInvent. So you're welcome.
Nicely done.
But the interesting thing here is that an IoT project without an identified business outcome is just a science project, which is what I just did. I built something that was technically working, can have a great architecture, but it didn't serve any business purpose. And we've seen that customers that were most successful, they start there. Before building anything, you go to identify a business outcome. And everyone, that principle applies to everyone, because even if you're in a technical role and a developer, you should be interested and invested in the success of the project as well.
Yeah, so actually, I want to say that one more time, because if there's one thing we want you to leave with is this is something we've seen across our customers across the globe, is customers who identify that business outcome as early as possible in the prototype or pilot phase, they are the ones who succeed. They're the ones who are seen. So if you're a device engineer and you don't know the business outcome, you should pull the alarm cord. You really should, and try to get that from the business and from the project that you're on. So it's really, really important.
And the second one is that the project should last no longer than a year, 12 months. Otherwise, they become too big, too complex. And also, if you're doing your project in a year, it's a good forcing mechanism to make sure that you can validate those business outcomes early on, usually in the first 4 months of the project. And when you start by doing that, then you can work backwards from your business outcome. And we have this concept of MVD, for minimum viable device. In the very early stages, when you're prototyping, you don't need the hardware. You can use simulated data and show the dashboard that you're supposed to build to business users to validate that the KPI you're working on are the ones that they actually want to see. And then once you know that and you know the data that you should produce from the device, then you can go on and build the device and just produce that data. No need to make it overly complex and add other things to the device. And the last one is customers told us that they needed help. And it's very understandable because when you're doing an IoT project, you need a very broad set of skills. You need people who are doing embedded programming using real-time operating system and C languages, all the way up to machine learning and AI technologies and everything in between. So please leverage the ecosystem of partners that we have. You also have a team of professional services and training available. So I cannot stress this enough as well. Don't be afraid to get help in your project. It's going to secure the project and also accelerate it. And actually, Jeroen and Federico here are a great illustration of that kind of work. So you will see that later in the presentation. So I'm going to hand it off back to Brett. We're going to talk about the anatomy of an IoT project.
Thanks. All right, so let's go in one level from the high-level ones that are for everyone, and now a notch more guidance about the anatomy of IoT projects themselves. So starting at a high level, we've found some key dimensions that customers need to consider early in their design of their project, and it actually influences the success of their project overall as well if they take these into account early on. And one of the key dimensions is number of devices. But this actually bifurcates really early as well, we've seen across the globe, is you can have on one side consumer projects such as a smart lock, where a smart lock is going to be deployed as an IoT project for the customer who's building this capability. And oftentimes the number of devices can reach into the tens of thousands, hundreds of thousands, even millions for often consumer situations. But then on the other side, you have industrial, where maybe in an individual facility there could be tens of thousands of devices, and you might have multiple facilities with this, but it's never looking at the level where the millions of devices tends to show up. So on the dimensions of number of devices, that's one that you can use to kind of box where your project's going to land. But there's another that gives you a second dimension, and this is data volume per device. So interestingly enough, on the consumer side, even though there might be millions of the devices that are out there, the amount of data that they actually produce is pretty low. They might be on an off state, they might be a open closed and a smart lock, but really overall, the amount of data that's produced by these consumer devices tends to be on the low side. But understanding that in your project is going to be key when you design your architecture moving forward. And then on the industrial side, it goes the other extreme. The data that can be produced by individual devices in an industrial facility can be voluminous. It can be huge. It tends to cover multiple sensors at once at granularities in the minutes, seconds, and milliseconds, even faster sometimes. And it's pumping locally and performing processing locally, and then flowing into the cloud when there's bandwidth to provide that as well. So these two dimensions we're finding are at least some indicative ones of success out of the many dimensions that could possibly be included in your IoT project. But if you take these into account, there's actually some things that are the same across every project we've seen. And one thing we've seen in every region we've talked to customers is customers tend to break down their IoT projects when they're successful into 4 phases. And we're naming these today of prototype, pilot, limited production, and scaled production deployment. So regardless of the dimensions you might have discovered are key indicators for your project, customers are breaking it down into these 4 phases. So let's kind of go into what these phases actually mean. So you notice at the top, so we're continuing on with the persona that's here. So some of the more indicative persona of success in the prototype phase are your product manager being involved, the cloud developer being involved, and the device engineer. But what the goal is often in the prototype phase for the successful projects is to validate that business outcome. They do this with 10 things or less, no matter what, if it's industrial or consumer. This is in an actual development environment that's set up for the project itself. And really the guideline here in the prototype phase that we've seen leads to the success the most is go as fast as you can. And as Michael mentioned, the MVD is a key thing to understand in this phase. But the output from here should be approval from a business decision maker. So then with that output, we can now go to a pilot. So in the pilot phase, the most indicative roles for success that we found are the technical roles that are in the mix. Because the goal in this is really testing and familiarizing the team with the technologies that are going to be used in the project itself, a little bit more than the prototype team, and getting a little more broad into the organization as a whole. The fleet size tends to go up a little bit, 10 to 100, often in the consumer, and we see that as well in the industrial too. But on the industrial side, one of the interesting things that shows up early in the pilot phase is trying to replicate production already. So a very early replication of production in the pilot phase is a really good indicator of success for the project team. And then here again, iterate, iterate, iterate in the pilot. So if you don't yet have your business outcome clear, you can further refine it. And the goal here is to actually have the concrete business outcome scoped in your pilot and a blueprint, because the blueprint is what you're going to take then into your limited production phase. So at limited production, again, the technical roles are the key indicators of success here, because this is all about testing at scale. This is whatever your scale is for a consumer or for an industrial deployment, really doesn't matter. It's if it's at the scale you're expecting to release to your customers. In the consumer side, it tends to finally grow up to the thousands of things level. You're on the industrial side, you're reflecting truly what production is. Customers might try this if they have multiple manufacturing lines. They might try it in one manufacturing line in a production setting where they can watch the KPIs that are coming out of there to see if they are actually producing both the visibility they want and allowing those KPIs to then have feedback into the team that's vetting this phase. And the output here then becomes a rollout plan that then you take into scaled production. So now here, by the time you're looking at scaled production, this is where everybody's in the pool again. The goal now is to just fundamentally roll out the product and deliver the solution. The fleet size tends to be unlimited from the perspective of the project. That, again, if you take the dimensions into account, it's unlimited in the orders of magnitude that you might have expected up front, but it's ultimately unlimited. You're kind of unleashing the product into the world. It's truly production, so it's environment. The key guideline here is to do what you can to roll out gradually. So if you have a target, try to roll out quarterly, more and more chunks, or if you have a horizon that maybe marketing's going after, then to chunk your way towards there. And it's ultimately because you want to have the ability to roll out and then monitor, roll out and monitor, because although limited production might have been fully successful, there's nothing like reality, right? There's nothing like real customers touching your product and actually growing with it over time. But there is actually an output from scaled production as well. And in scaled production is where you can gather feedback, where you can actually use the KPIs that you've produced over this time to provide insights, maybe 6 months, maybe a few years later, into the next generation of the product you're going to roll out to your customers as well. So let's bring all that back into these 4 phases. So here you can now see prototype, pilot, limited production, and scaled production deployment. But there's a couple other concepts that you might want to layer onto your thinking. Is often the technical validation is going on in the earlier stages from prototype, pilot, and into the beginning of limited production. And then the business validation tends to span that whole phase. Depending on how early you're comfortable bringing customers in, it might start in the prototype phase, depending on your relationship with some of them. But it definitely must happen before you exit limited production. Because at the end of the day, what you want when you're going to when you're exiting limited production is to have a validated business outcome, because that's going to be your best indicator of success from the business around you. And this, and this actually happens when you take the 12-month chunk. The guideline is you should be able to do your prototypes in weeks to months. Your pilot should be in about months, and your limited production is about months as well. And so they add up to that approximately 12-month guideline. One piece here is 12 months is not a hard, fast rule, but the act of time boxing your project to 12 months is the key benefit. It's the from the beginning, say we've got this long of a runway to get success. It brings forward that business outcome as early as your organization is going to be comfortable with. So with that, we're going to go one layer deep now. So best practices from Michael.
Thanks, Brett. Thanks. And one thing before I go there is also the fact that those business outcomes, they have to be validated during the whole project. It also makes people work together, and that's also a very important criteria for success, to have all the persona that you've seen before all working together. So for the best practice in this section, what we wanted to give you is a few examples of those best practices, so that when you go to the implementation in your project, you can remember when you design an architecture or when you start developing that there's patterns that you can reuse. And so that way will be in the back of your mind, and then you can go back later on to that presentation or online. And the first one is, before you start, especially for the technical roles, read the white papers. We have a few online, and we have just released a new one, which is called AWS IoT Lens, and that will enable you to avoid common pitfalls. The second thing is to have a unique ID for all of your devices. That way you can clearly identify them. And the most important part is to use that unique ID everywhere. So when using IoT services, you will use that as the thing name in the device registry, and also as the MQTT client ID when you will establish an MQTT connection. And by doing so, you will enable very fine-grained security, and you can have permission on a per-device basis, and you can control those actions very granularly. The other thing is that if you're looking at your logs, that could be operational logs or even in the data, you will be able to identify where is that coming from very quickly. And so you don't have to maintain other tables with mapping and identificator to your devices. Talking about MQTT, so for those who don't know, when you're doing IoT, you usually use a protocol that is called MQTT, and it's a publish-subscribe protocol. So you're going to publish messages, information, on MQTT topics, and you're going to subscribe to those topics to get the information. And you can choose different topic hierarchy, and again, in our white paper, we give you guidance there. But the key best practice is really document whatever convention you use. That way, everyone can have access to it on the project and can use that convention. And you can see at the end of the topic hierarchy here, we're mentioning the device ID. All right, so talking about the payload now that you can send from devices. So again, you see the device ID there. That information will be accessible everywhere. If you have downstream services processing the payload, it will already be there. One other thing that is very important to include in your messages is a timestamp. Why? Because most of the IoT data is going to be time series data. And you've probably seen that we launched Amazon TimeStream. And having the timestamp in your messages, it will enable you to cross-reference information. And also when you deploy your project globally, we recommend to use formats that have been proven, like the ISO 8601. And that way you can take into account multiple time zones. So now that you're sending messages from your devices or making API calls from your devices, what happens if your backend is overloaded? Well, you're going to retry to send that message or to make that API call. And instead of having an interval of time that is the same, we recommend that you implement exponential backoff, meaning that every time you retry, it's going to take more time in between the retries. Adding a little bit of jitter, so a random short period of time is also a best practice. Why? Because if you have all your devices waking up at 2 p.m. to send an information, and they're not successful because the backend is too busy, if you have a bit of jitter, it will help spread the load across the time. One thing very important is to implement as well a maximum period of time between two retries, because otherwise it will just keep growing and growing. And that maximum period of time, it really depends on your use case. For some customers, it can be 10 minutes, an hour, some a day. So that's up to you, but don't forget to implement a maximum period of time. That's also a best practice. It's a best practice for your cloud backend. That way, they can, if it has failure, it can recover. But it's also a best practice from the device perspective. Because usually on devices, you can be using batteries. So doing so will enable to save you CPU cycle and also bandwidth. So that's saving cost to send the data. And also, it's better autonomy for your devices. So now that you're sending a lot of data, if you remember Brett's slide in the industrial context, in that context, a lot of data is going to the cloud. You can use Lambda Function to process the information. And instead of having one Lambda function executing per message, what we recommend is that you funnel all that data to Kinesis data stream and then have Lambda Function executing and processing the messages in batches. So that way you can process 100 messages at a time. An added benefit of that is that using Kinesis data stream, you can retain the data up to 7 days. And talking about different patterns of architecture, really excited to announce the launch of the IoT Atlas. So it's a library of different designs, common design that you will find in the IoT world. Everything is open source. It's online, so now you can go to that address, iotatlas.net. And if you see a design that is missing, please contribute. Again, everything is open source. It's on GitHub, so you can propose and suggest your own designs. Following up on that, we usually get the question from customers, how do I implement command and control? And you can start by asking yourself a few simple questions. If it's a fleet-wide operation that you're trying to perform, we have a service for that called AWS IoT Device Management. So take a look at that and use it. If it's just for one device, you can use what we call Device Shadow to implement command and control. It also has offline capabilities. And if you have other constraints, then you can look at doing command and control just using the plain MQTT protocol. All right, so last but not least, one of my favorites, friends don't let friends subscribe devices to pound or hash. What does that mean? So if you have that line of code in one of your devices, when you subscribe to pound or hash, you receive all the messages that are sent to the IoT broker. So of course, that's probably way more than just one device can handle. So don't do that, and be very aware if you have that line of code in your source code. It also ties back to the first best practice. Remember, your MQTT topic hierarchy is documented, so every developer should use the direct topic that they want to use, or using subtraction character, but again, not pound or hash. And you can find many more information in training that we have online. We're also launching at re:Invent this week a new series called the IoT Foundation Series. It is free training. It's based also from some of the pattern that you can see in the IoT Atlas. So after this session, go online again. Feel free to launch a few training, spread the word as well. And we have 4 modules for now, and we'll keep adding more module over time. And now I'm going to welcome Jeroen from Pentair on stage and Federico, and they're going to talk about their project and how those, all those phases that Brett talked about relate in a real use case. Right.
Thank you, Michael.
Thank you, Mike. Thanks.
And Brett, of course, also thank you. Let me quickly try to set up my gear. Because I also have a button. Yeah? We're going to find out if this is the second worst demo. So thank you, Michael and Brad, for allowing me to be here. It's an honor to be invited to a stage like this. And today I would like to take you to the steps we've taken over the past 18 months. We didn't make it in 12. Maybe a year ago it wasn't 12, it was 18. Who knows? On our digital transformation. So we really tried from a Pentair perspective in our filtration solutions business to see how can we create a new solution that meets the needs of our customers. But to give you a little perspective of what Pentair does and what filtration solutions means, we have prepared a small video, and then they taught me to push a button here, and then I can be quiet for a couple of minutes.
Enjoying beer responsibly is something special. It's when we share our best stories and make friends. We love to drink our beer together with people we relate to and can have fun with. Our great passion for beer can be motivated by many sources: personal taste, a regional association, or just an old-fashioned attachment to a specific brand. Brewers all over the world give their best every day of every year. They're passionate about their job, but even more about their product, constantly endeavoring to craft the perfect beer, which they can take full ownership of. When it comes to hygienic processing, you can rely on Pentair Sudmo. With an unparalleled valve portfolio and one of the most innovative application engineering capabilities around. Maximize your process uptime and achieve reliable, trouble-free operation through optimized control, maintenance, and cleaning. Assure product quality and enhance O2 and CO2 management with Pentair Hoffmann's wide range of quality control equipment, in-line, at-line, and in the laboratory to meet the highest expectations when it comes to shelf life and product excellence. Pentair's beer membrane filtration systems enable you to save on waste disposal and product loss, while brewing a bright beer without bothering about the handling of DE. But since the goal is to produce the best and most consistent beer quality, one cannot overlook BMF's measurable improvement to the beer's taste and colloidal stability. Improving performance and process while meeting environmental, health, and safety challenges is more important today than ever. So nurture your brewing process ingredients, capture and use your food-grade CO2 with Pentair's recovery systems. Operating a state-of-the-art production plant requires just-in-time processes, preventing downtime before it happens and meeting tough quality regulations. This is where Pentair's Serious Service program comes into play and takes service to the next level with preventative maintenance and the Internet of Things. Avoid water scarcity and reduce energy use, disposal costs, and water loss with Pentair X-Flows membranes. Pentair's Helix Flux Enhancement technology is the breakthrough innovation in wastewater treatment. Helix delivers up to 100% higher productivity and up to 50% energy savings. As constant quality, flexibility in the process, and resource efficiency is key, this is exactly where Pentair is helping our customers in the brewing market. Together, we strive for superior process safety, meet the highest standards, expand the product variety, and react to fast-changing market requirements and environmental excellence. For life.
You want to push the button? Let's switch back. We had the video. So it's all about beer. Beer membrane filtration, that's the main topic. Maybe tonight it's about the beer we're going to drink together. But we have to produce it, and I think we are the world leader when it comes to beer membrane filtration. With approximately been around the technology for 15 years now, we have produced worldwide over 300 billion glasses of beer. And that is more than 40 glasses of beer for everybody on this planet. And with our new connected equipment, and especially AWS, we are running on the back end, we can implement and boost that performance of those systems. We expected and calculated with approximately 1.5 billion glasses of beer per year. I did the math, looked up the number of people that live in America and the average consumption of 74.6 glasses of beer per American. That leads up to 5 million Americans. So every year for 5 million of Americans, AWS will bring you the beer. But that's not just one part of our process. So it's not about making more beer. It's also about reducing water consumption, CO2 consumptions, lower the OPEX and CAPEXs of our products, and in the end, making it more sustainable for the environment and, of course, the financial gain which our customers will get from that. Now, the first phase, prototyping, like Brett and Michael said, you start drawing something. So we also start drawing something on a board. We have in black the traditional system, where we have a PLC connected to our BMF, and we have a SCADA system running on top and an MES layer. We extracted data. We started doing that 15 years ago. When we introduced the technology, we straight away started collecting that information. We had to find a way to get it out of the production facilities of our customers, which is actually quite tough, and it's become more and more tough. So we see customer needs changing. They want to have more flexibility. They want to be able to change the way we extract the data, the reports we make, because they want to go more into production yield or a changing product portfolio, which means the traditional process, what the plant was designed for, is going to change over time. And how does that affect their KPIs of the production plant? We also encountered a lot of legacy architectural limitations. If we have to transmit data through internet networks, VMs, VPNs, firewalls, it takes about 7 firewalls to get the data from the BMF into our own data center. We all know of our IT departments. Our firewall regulations keep changing day over day. So you can imagine we have, at this moment, 2 people full-time working on maintaining 20 connections. Multiply that by the number of plants we have, and we have a nice room full of people watching connections. That's not sustainable, so we have to change. So one of the biggest lessons we learned is we have to also be ready to embrace change, and we have to identify also the shortcuts we have taken in our current setup. So we have been struggling to figure out how to maintain our current system, and it's led us to basically say what needs to change. And the number one that came to our minds was the mindset of everybody who's working on the BMF as a product. We have to learn to accept that data is a part of the product and not just something our service team would like to have to know what they're working on. And we have to also learn that the cloud has to become a part of the product, because our existing landlines will not support us and will not bring us the scale we need. So we have to change. We got a green line to start prototyping, and we reached out to AWS, and we had a really nice encounter with a prototype architect. So we learned to build our own AWS experience. And during that session of 2 days, we thought, let's test some extremes of what we think AWS should be able to offer us. We straight away learned that AWS IoT 2 years ago had limitations. And the limitation is about 333,333 events per minute for over a time period of 5 minutes will trigger a DDoS attack flag on AWS IoT. We thought, okay, before we hit that kind of numbers on a single product, we are quite okay. That gave us confidence to find a new comfort zone. So we tested more limits, and we went away from testing the limits of AWS to finding out what are actually the limits, what we can do inside our product. So instead of relying on a PLC technology that has been around for 40 plus years, we thought, can't we control our systems with a single board computer? And that in the end led to, Federico, we all know this little piece of device. We buy it for $35, It's called a Raspberry Pi. And today, it's the new standard of our BMF systems in our industrial space. This is the new controller we as Pentair supply to our end customers. And then people say, how did you manage that everybody trusts you putting in a Raspberry Pi? Well, the convenience of this single-board computer beats the limitations that were in the architectural in the legacy. So this one is opening up a whole lot more new possibilities than the one we had in the past. So we really defined a new comfort zone for our product and our customers. So what did it open up? It opened up the fact that now all of a sudden we can communicate to the cloud in a very easy way, because we just have the internet connectivity on board. We don't need additional machines and computers to route traffic. We just need somebody to open up a firewall port and we're good to go. Once we have the data in the cloud, you can get a mobile app, read the data through a mobile app, get push notifications, notify your operators when they need information. So there were a lot of new things we learned which actually made our business model change. The entire way we set up our service model is going to change. In fact, it has changed because 2 weeks ago we announced our complete new service program we run throughout our entire FBU business. We're now going to be focused on bringing service on a mobile way to our end customers. Like I mentioned, we defined the way we do our service, but it's not only on the service part where we changed. We also changed on our product management goals. So from being a vendor supplying just a machine to somebody, we said we want to be in the space where we are the strategic business partner of our customers. And that means we have a much, much tighter relationship with our customers now than we had a couple of years ago. We also set some new product management goals. You want to challenge yourself, right? Like mentioned on the previous slide. What we plan, we filter is the new motto. So we don't want to be reliant anymore on changing inputs to our BMF. Whatever the customer gives us, we should be able to handle it. If not, we should warn the customer that we're going to have to adjust something. So we have to become predictive, and even more stronger, we have to become adaptive. So we have to adapt to a real-time changing condition, and our systems need to handle that. So we estimate with connecting to AWS that we can boost at least the overall performance of our systems with over 3%. And our products now don't wait for an operator to act. Our machines now reach out to the operators. They send push notifications when something is wrong. So the product is asking for assistance when needed. That also led to another benefit for our customers. The operators no longer have to sit and watch behind a computer screen 24 hours a day if a fully automated system makes a mistake or something goes wrong somewhere in the process. The traditional operator has now become a maintenance manager. He's doing his routines in the factory, and whenever our machine needs service, he will send a push notification, and the engineer will go to the machine and fix the issue. So also in this phase, in the pilot phase, we really enabled our customer interaction. So with the new technologies discovered, how do we sell it to the customer? Because we also want to make money, right? And the best way we thought to do is just get them involved. So we pulled in our customers, and I had a slide, one of the first slides. Maybe some of you saw the logos. They are the big brewing chains of this world, the ABIs, the Heinekens, the Mollekors. Those big players in this space, they just want to focus on brewing beer. They don't want to be bothered anymore by, does my machine work? Do I need a technician who knows the technique of this machine? So we are basically servicing them from the start. And together with 2 or 3 of those chains, we developed the product and especially the analytics on top. So we opened up what we did. They have seen everything, how we build it, when we build it, what we change, how we're going to change. And it's not a joint development because we developed everything, but our customers know upfront they are buying into the solution that comes out. And that's what actually triggered our digital transformation inside the company, because now technology had the advantage over the rest of the business, because we had already the customer wanting to buy our product while it was still under development, and product management and sales still had to come up a way for, okay, for how much do we actually sell this cloud technology? That's a nice position to be in. We created in the pilot phase a slim architecture, and I'll walk you through it a little bit. We start on the factory side. You see the edge. We added AWS Greengrass. 18 months ago, it was still in preview. So when we heard about it on the doorsteps in Seattle, when we visited AWS as Pentair, it was not an official service back then, and we said, but this is something we need. If we want to make a move in the industrial space, we need to have local compute capabilities in a secured environment. So that's the basic building block of our house of IoT, how we like to call it internally. Then we added up the IoT services. When we started, it was only IoT Core. Along the road, we learned IoT analytics. What is it? We found out, and we thought, hey, maybe we should try this one as well. So while developing in our pilot stage, we kept reinventing the wheel with new services coming up from Amazon. And it wasn't just IoT analytics. The same thing happened with AWS AppSync. So how do we query our information to our dashboard? We don't use an API gateway. Many people still use it. We think it's old technology. The new technology is the GraphQL queries, where you can real-time change your queries to your backend without changing the application. So AppSync in that case makes your front end really dynamic because you can on the fly change what you want to query from your backend. And we had some other cool stuff under the hood. It's not on the slides, but at least Amazon QuickSights there, that's the output, of course, of what's being developed with SageMaker and machine learning and ML inference. And I think we've heard a lot of those sessions over the past couple of days that ML and SageMaker is a hot topic, and we're ready to implement it under the hood, and hopefully we can bring it to our customers early 2019 as a commercial product. We also learned really fast in this stage, mid last year, or mid this year actually, we need to build our own DevOps team. Otherwise, we are never going to be able to keep up with the speed of AWS. They are releasing so fast new features and services. We need to leverage more people. So we set up a team of 8. We started off in April, and I'm proud to announce that by now we're about a team of 40. And we're not just doing it anymore for the BMF, but the rest of Pentair has seen what we have developed and said we need to develop the same capabilities for our product lines. So we're scaling quite nicely internally to really digital transform from a hardware builder into a software company. And then I had a real nice demo set up, and hopefully it's going to be nice, or it's going to be really the best or the worst demo of reInvent. I should switch again.
Yes.
This is what we call a just-in-time recovery, Brad. I can show you guys a couple of minutes ago the dashboard crashed, so it wasn't working. Yeah, and thanks to the recovery mechanisms on the back end, it's back up. So we have a complex system I should be able to show you if I click the main button, which is actually running on this Raspberry Pi.
Yes.
Here we go. This is the control mechanism of the industrial installation. And I don't know if any of you know what a traditional SCADA system looks like, but there you have hundreds of controls and a lot of pictures that look more like this page. This is what a traditional SCADA system looks like with our BMF on the right side in the green lights, in the green lines. This is something brewers are used to working with, people in industry are used to working with. They hover over information and they see stuff happening. But we thought we have to change it because this is not going to be sustainable for the future. It's too complex. We can do it simple. And we took away 90% of all the information and placed mainly the main KPI in the center point, which is the transmembrane pressure. And we now have a simple gauge that goes from low to high, and we can predict to the end user when do we need to go for the next step in our systems. And when something happens, like when I push this button, it should basically trigger an alarm. It should shut down the installation. So now the alarm is in health state. It sounds really simple use case, but in fact we are using a dash button through AWS, through SNS, which is actually writing down, sending me a push notification to my mobile app, telling me something's wrong in the installation. So instead of having to be around the installation, the operator can walk around freely. And in the mobile app, he can then basically see the notifications of what is going on, and he can acknowledge the alarms from his mobile phone. We don't allow the operator to remotely restart the application. That would be taking it, I think, at this stage in time, a little bit too far. We're a food and beverage industry, which means we kind of like to keep a good product quality. So if something's wrong, somebody needs to go and check before we continue. Not today. So I'll just push the button and it should continue. And it's running again. And we also created some other, and we get the push notification that the alarm is resolved. We also developed another feature which our customers really liked, and it was a feedback that we got from our customers. It says, can you create something for us which will enable us that my operators can, during night shift, easily hand over responsibilities for the alarms, so that we're not forced anymore to just sit at the installation even during the night shift. So we created a function inside the mobile app which allows us to hand over mobile phone subscriptions from one user to another user. So I can simply select a colleague of mine and I give him the push notifications. And I have to click accept on my phone. If I find the push notification, accept. And now my phone is receiving the push notification, and this phone is no longer receiving the push notification. It seems a really simple use case. Maybe too simple to be cool. But it's actually the biggest problem in industry. Solving the fact that operators fall asleep during the night, and the plant suffers 2 hours downtime because the operator is sleeping. We did some math on what is the business value of this little feature. If an average plant has a downtime of 2 hours, they lose about $12,000. So I think it's a good business value for them if we can save them one downtime a day by keeping the operator awake during the night. Something else came out when we added the Raspberry Pi instead of the old traditional PLCs. We need to switch back.
Oh, yes.
We did some cost calculations. Traditionally, on average, we pay about $30,000 on hardware on the inside of our systems. it's been around for decades, so we all know what the cost price is, how it works. Then a couple of years ago, we were already experimenting with soft PLCs and SCADA systems, so we were able for smaller installations to bring the cost down to about $5,000. And now with the Raspberry Pi, we're able to bring the cost down to $1,000, of which $750 is the 15-inch touchscreen. So it's $250 for licensing, soft PLC, and controls. So we save, on average, on every installation we sell today, compared to yesterday, about $30,000 in savings. It's 26,500 in euros. So that's a huge cost saving. It's the business viability to move on. So the business case is not just our customers wanting to have it, but we are saving money in the process and creating a new product which our customers are willing to pay for even more. The next phase, the third phase, limited production. It's time to make it real. So we did that about 13 months ago. The first pilot we put it straight away into production. It's been running for 12 months in stable operations at a brewing installation in Germany. And it gave us a real nice, real-life feedback, and the customer doesn't want anything else anymore. He even asked us, can't you automate the rest of my factory with the same device? But when you make it real, you have to also think into some other points. Security is going to be a major topic. I mean, when you're playing around, it's nice and cool. But is your solution 1,000% secure? We didn't know. So we asked professional services to come into play and just do a security assessment and threat modeling of our solution. So we contacted Federico's team, and they spent 3 weeks.
Yes, on site.
Yeah,
Yes,
something like that.
Nice timing there.
Yeah, 2-3 days a week for a period of 3 weeks. And they assessed everything we built. They gave us recommendations. We on the fly changed and modified all the things that were found that should be improved. And 3 weeks later, we had a nice report in front of us, which we can share with our customers again, that the solution we build is up to the standards of AWS. So what we've actually learned is that you need to orchestrate for scale when you're in limited production. And what does orchestrate for scale mean? You have to make sure that you're up for the security reviews. If you're not ready, spend some time. Spend some money there. Those couple of weeks of professional services, they pay themselves back really fast. One mistake, and once you're in full production, I don't think you will ever regret paying that money to somebody else who is the expert. Something else we learned in this phase is also that the BMF is not going to be the only product we're going to bring to the cloud. So we also have to build a framework as Pentair where the entire enterprise can leverage from. Because there is a lot of common resources in the back end. But if it's all in a single account, it's only going to be useful for a single product. You want it to be available for all the products we want to bring to the cloud. So we again went out to professional services, and Federico will explain in 2 slides what they did, so I'll skip the details. But they made a real nice framework for us, and I think it's the predecessor of the guard tower. And we engaged in new initiatives. So we spread the word internally, and we spread the word externally. So I'm not afraid to share our story with external customers. They can ask us, no worries. It's open source. Everybody can make the same on AWS. The first account is for free. The minute you start spending money, AWS will love it. The last one, scale production. So now we're going to deep dive in a single product, in this case the BMF. So play around with ML, IoT analytics, see how far we can get into adaptive processing. We have onboarded by now 3 other product lines from Pentair. So we're scaling in multiple dimensions. We're finalizing our OT-IT integration. Initially, we were fully independent of the IT organization, but that won't scale over the entire enterprise. We have some regulations we have to live by, so there is a small integration part, but it's really small. And everything we build is fully automated. So we have everything inside the framework running through pipelines, cloud formation stacks, and step functions. So we can redeploy a new ecosystem in about 10 minutes, and we're good to go with another product line. So scale in multiple dimensions is the major lesson we learned just before we moved it to scale production. And with that, I think I'll give it to Federico.
Okay. Thank you very much, Jeroen, for this nice explanation about the project. So my main contribution to this session is to explain a little bit more in detail how the partnership between Pentair and AWS was established across the different project phases. So looking at the prototyping phases, the main objective here was to help Pentair team get better understanding about AWS cloud capabilities in order to assess what services were more relevant in order to be introduced as part of the target architecture. And as the outcome of this cooperation was a strict relationship between the solution architect team and the prototype architects with Pentair team in order to launch a series of proof of concept able to validate the different capabilities that were included in the original scope of the solution. And this helped a lot to make the Pentair team, let's say, more confident about the services that should be included in the solution, as well as to establish the proper link between the Pentair organization and AWS, both in Europe and US. Moving to the pilot phase, this was the phase where the professional service team was involved into the project in order to move the initial implementation to the next stage. So here, when my team embraced this project, we started running an architectural review in order to validate that the proper AWS platform components were properly used as part of the target solution. So we ran an assessment on different solution components, including Greengrass running on a Raspberry Pi 3. And then after the assessment of the edge components was completed, then we moved to the next phase of the pilot by assessing and providing a strict guidance to Pentair in order to properly design and implement the data ingestion and processing workflows. And here, basically, we leverage the capability that AWS IT provided in order to let Greengrass to send the proper data using MQTT protocol by adhering the established practices that were introduced in this section in terms of topic structure, in terms of payload, in order to have, let's say, the better visibility of the data in the cloud, as well as we went through the proper ingestion workflow, leveraging as much as possible managed services like Amazon S3, IoT, and Lambda and Dynamo as part of the solution component. Moving to the next stage, the limited production, here a strict focus was put on two main topics, security and deployment. From a security perspective, we helped Pentair conduct a truthful security assessment and threat model on the solution in order to identify, let's say, all the best practices that should be enforced when moving the solution into an industrial production environment. And this was, let's say, the first outcome of this project. The second outcome was to speed up the deployment as much as possible by leveraging automation. And here we helped Pentair providing a deployment framework that can accelerate the initial provision of the environment as well all the ongoing enhancement of the infrastructure and the application component. And just to give you an example on how the deployment framework works, the deployment framework is able to manage and operate a runtime environment that includes multiple accounts that are basically built on purpose to address a specific solution components. And this provisioning is done by supporting the bootstrapping of new accounts. So as soon as a new account is included as part of the solution using AWS organization through organization unit, the proper bootstrapping process happens at account level in order to ensure that This account adheres to the established DevSecOps best practices on one side, as well as the proper solution component are deployed as a part of the account of the account baseline. And moving to the next step, to the scale production, what we look here at partnership with the Pentair is to enable as a Pentair to scale this production from a single product like BMF to the entire product portfolio. In order to ensure the proper scalability of the solution, we should basically leverage also partners that will work closely with Pentair in order to make this solution to be a successful standard across the entire organization. So what we expect from professional service perspective is that our long-term relationship with the Pentair will continue, but in a different way how it was managed in the previous phases. So we see how as an accelerator for the enablement of Pentair partners, as well as an accelerator to deploy new services that will let this solution to scale in terms of functional requirements over time. Okay, so I will hand over to Jeroen for the conclusions.
Thank you, Federico. Yeah, so one last slide of our conclusions. We split it in two parts. One is the business transformation, and the other one is the technology development. So first one, we said we want to work with cutting-edge technology. But that actually led to the fact that the business needed to be ready to embrace those changes. Otherwise, cutting edge is cool, but it's just going to be a science project. Then we learned that we had to challenge what we had done in the past and had to change over our complete business models. Find a way where the value is, so we changed our existing business model. We found a new operating rhythm for our product that actually will generate more revenue than the old model. Then you have to build your internal DevOps team. Without internal skills, it's going to be a hard journey. And I know for smaller companies it may not be easy, but even there, if you have an R&D or technology department, you have to have some people on board who know the products, your own products you're going to bring to the cloud. If you don't have the product expertise there in-house, that also have the skills to read what is being developed on the cloud side, if those two don't match, it won't work. And if those criteria are met, so you have found your new business model, you have a team of people that understands what they want to do, then you can initiate the digital transformation of your company, and you can start spreading the word internally. And once you've managed that, the final stage is orchestrate for scale. So be ready to actually scale your products. And I haven't mentioned it, and you didn't also, Federico, but our solution is based fully serverless, which means we are only relying on public-facing endpoints of AWS. If we have one device in the cloud, AWS will be our partner in scaling it to 1 million. So the only limits we are going to hit are the account limits of our AWS accounts. And with the framework built around it, it will take us 10 minutes to scale to the next phase, and we can double our capacity. So going full serverless and all in on AWS made us really say the BMF is a future-proof product, and we are hoping to build many, many more.
Thanks, everybody. So we're wrapping up now. I need the button. All right.
I'll press thank you.
And thank you for being here. Hopefully you learned something today, and we'd love your feedback at the end of the session. Please fill it in the mobile app. We always try to make these things better year over year. So thank you for your time.
And we'll be around if you have any questions.
That's right. We'll be over on the side if you have questions.
Thank you.